Hello, my name is Alicia Byer, and tonight we're going to be talking about divides, divisors, factors, and multiples. This is a little saying that I've seen. Always wear glasses to math class. They help with division. Divide. To divide or division is sharing or grouping a number into equal parts. Okay. I picked 12 divided by 5. Amanda, can you tell me how many times 5 go into 12?
2 times.
Okay. 5 times 2 is 10. So you'll subtract the 10 from the 2 and you're left with 2. Taylor, what would be the remainder?
2.
Okay. So 12 divided by 5 is 2 with a remainder of 2. Next, we're going to do divisors. A number or expression that another number is divided by. How to compute a divisor of any integer. Jessica, can you read step 1, please?
Rewrite number in exponential form as a product of unique primes.
Example, 18. 18 equals 3 with the exponent of 2 times 2 the exponent of 1. Amanda, can you read step 2, please?
Yes. Add all exponent combinations down to 0.
Thank you. 18 equals 3 with the exponent of 2 times 2 with the exponent of 1. So the exponents are 2 and 1. Taylor, can you read step 3, please?
Compute divisors using exponent combinations.
Thank you. The divisors of 18 are, it will be 18, 9, 6, 3, and 2. And it shows how, what numbers with how many exponents from that will equal the number. Now we're moving on to factors. Factors are numbers we can multiply together to get another number. Find all factors of 120. Jessica, what are the first numbers that we start with?
1 times 120.
Okay, and then we move down to 2. What times 2 equals 120?
60.
Okay, and then we will move all the way from 3 to 11 to see what numbers times another number will equal 120. Taylor, what are all factors of 120?
1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120.
Very good, thank you. Now moving on to multiples. A multiple of a number is that number multiplied by an integer. Which of the following numbers are multiplied or as a multiple of 14? Jessica, can you guess a number?
70.
Okay, well, we'll start with 14 times 1 is 14. Let's see which one is right and if Jessica was right. Now we'll have 14 times 2 is 28. 14 times 3 is 42. 14 times 4 is 56. And 14 times 5 is 70. So Jessica, you are right. Good job. Now I will move it on to Amanda.
Sorry about that. Okay, today we're going to be talking about divisors of natural numbers. Jessica, did you know that divisors and factors have the same value?
No, I didn't. How interesting.
What is a divisor? A divisor is a number which another number can be divided by. For example, what is a divisor of 5? That answer would be 1 and 5. That's because 1 and 5 is the only numbers that can be multiplied to get 5 or divided by to get 5. So how do you find divisors? You can have factor trees, you can do long division, and there's other methods you can use to find a divisor. Today we're going to do a factor tree example on how to find those. So for a factor tree, how you solve the problem is you take a number and you start breaking it down. First, you want to break it down into two numbers. Then you will see if they are prime. If they're prime, you'll circle it and then solve for the other number until those numbers are prime. So today we're going to start with 24. And Alicia, can you tell me what the first two numbers are going to be in the factor tree?
It'll be 12 and 2.
That's right, because 12 and 2 times each other are going to be 24. So since 2 is a prime number, we're going to circle it, and we're going to solve for 12. So 6 times 2 equals 12. So we're going to factor those, and we're going to circle the 2. Now we have 6. 3 times 2 equals 6, and those are going to be our prime numbers. And since they can't break down anymore, we're going to circle those as well. Alrighty. And Taylor, can you tell me how many 2's we have?
We have 3 2's.
That's right. And so we're going to write the number 2, and then those 3 2's are going to be our exponents. So we're going to put a 3 in there. So Jessica, can you tell me how many 3's we have?
We have 1 3.
That's right. So we're going to put that in for exponent of 1. So to determine how many number of divisors we have, we're going to use an equation. And the equation is D parentheses N equals A plus 1, B plus 1, and C plus 1, and those are in parentheses. The D is for divisor, the N is for the number that we're going to solve for, how many divisors there are. The A, B, and C in the parentheses are going to be the exponents that we solved for. So D parentheses 24 equals, so we're going to take the first exponent that we have, which is the 2's. So the 2 exponent 3, we're going to bring the 3 down and put it in the first parentheses, 3 plus 1. Then we're going to take the 1 3 that we have, the 3 exponent to 1, and bring the 1 down. Then we're going to solve for what's in the parentheses. So 3 plus 1 equals 4, and 1 plus 1 equals 2. And since those are still in parentheses, we're going to multiply those. So that'll be 8, which means we have 8 divisors for 24. Now, how do we find the 8 specific divisors of 24? So we're going to go down the number line from 1 to 10. So 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, and 4 times 6 is 24. And that gives us the 8 numbers we were looking for. So we have 1, 2, 3, 4, 6, 8, 12, and 24. And those are our divisors. Thank you. And now we're going to go on to Taylor.
Thank you. Give me just a second. Uh-oh. Let's see. Ooh. I'm pulling it up right now. Give me just a second. All right. Who would have ever imagined that something as straightforward as natural numbers could give birth to anything so baffling as prime numbers? A quote by Ann Stewart. My name is Taylor Avant, and I have 2 questions we need to ask ourselves about prime numbers. First, how do you determine if a given natural number is prime?
You can do that by solving for its factors.
Right, prime numbers are only divisible by 1 in itself. So let's see if 4 and 5 are prime by finding its factors. Starting with 4. Multiples of 4 are 2 times 2 equals 4, 1 times 4 equals 4 as well. Next we have 5. 1 times 5 equals 5. So that tells us 4 is not prime, but 5 is prime. Here's a small list of other prime numbers. But is that all of them? No.
No.
So how many more are there? Is there a large prime number or is there an infinite set? Take a guess.
There are infinite prime numbers.
Yes, right. Euclid gives us proof by contradiction. So let's see how he did it. Let's assume that there is an infinite number of primes. Our set is 2, 3, 5, 7, and 11, so on until p, which would be their largest prime number. Euclid introduces a new number x. X is a product of 2 times 3 times 5 times 7 times 11, and so on to times p being the largest number. Then we're going to add 1. And once we get, we add 1, then we see that x can't be divided by any of the numbers in the list because there will always be a remainder of 1. Let's look at this with a more real example of a set. Our set is going to be, which we're assuming is all of our prime numbers that exist, is going to be 2, 3, 5, and 7. If we multiply them together, what do we get?
211.
Right, that's when we add the 1 as well. So now 211 isn't divisible by 2 or 3 or 5 or even 7. So that tells us that 211 is either divisible by some other prime that is not in the list or is prime itself. Either way, this gives us a contradiction. Still doesn't tell us what the largest prime number is. As of the current record being held for the largest prime number is currently 2 to the power of 57,885,161. Written out, this number contains 17,425,170 digits. Amazing, huh? Well, thank y'all for listening. I'm going to pass it on to Jessica.
Thank you, Taylor. Today we're going to learn about prime and composite numbers. Taylor, did you hear about the conversation in between 53 and 59?
No, I didn't.
53 says, we're in our 50s, we're over the hill. And 59 says, what are you talking about? We're in our prime. My name is Jessica Johnson, and let's talk about prime and composite numbers. Amanda, what do you think about the number 185? Do you think it is prime or composite?
I think it's composite.
Okay, let's factor it out. We know we can use the 5 test because it has a 5 in the ones place. What number can you multiply by 5 to get 185?
Let's try 37.
You're right, but how can we know if numbers are prime or composite? Does this really tell me if it is prime or composite? This doesn't really. Or does it? What are prime numbers? Prime numbers are any natural number that has a factorization of itself in 1. 1 will not be a prime number. In our example, we have numbers 2 and 3. As you can see, when they are factored out, you get 1 and themselves. Don't let the term natural number confuse you. A natural number is any positive integer that is on the right of the 0 on the number line. Basically, they are counting numbers. What is a composite number? A composite number is any natural number that possesses more than 2 different factors. The example we have here is 12. 12 has several different multiples. Even though we have 1 times 12 equals 12, there are more natural numbers we can use to come to 12, such as 2 times 6 or 3 times 4. You can use factor trees to help know if a number is prime or composite. Let's practice. Alicia, let's factor out 369. Where would you start?
I would start with with the threes test because 3, 6, and 9 are all factors of
Okay, let's start with the threes test. Add 3, 6, and 9 together, and what do you get?
18.
What if you're still not sure? You can take 1 and 8 together, add them together, and what do you get?
9.
Okay, so we know that our threes test works on 369. Let's factor it out. What number times 3 gives us 369?
123.
Can 123 be factored out any further?
Yes. 3 times 41.
Can 41 be factored out any further?
No.
That leaves us with 369 being composite and 41 being prime, because 369 has multiple natural numbers and 41 has natural numbers of 1 in itself. Amanda, what is a prime number?
A prime numbers are any natural number that has a factor of itself in 1.
Taylor, what is a composite number?
Composite numbers are natural numbers that have 2 or more different factors.
Good job, guys. In closing, I hope you have a better understanding of factors, multiples, prime numbers, and composite numbers. Remember, keep calm and love math.